Hi, in this section we will be covering how to do a hypothesis test to make a decision about a proportion. Hypothesis test for a population proportion. And as we'll see that this method of doing a hypothesis test, it really follows the same basic structure as doing a hypothesis test about a mean. It still involves establishing our hypotheses, computing a test statistic, finding a p-value, and comparing that p-value to our value of alpha in order to make a decision. The main difference is that because we're doing it for a proportion, then the formula for the test statistic comes from the central limit theorem for the proportion. So let's dive in and cover how to use the p-value method to test a hypothesis about a proportion. Let's start by introducing an example, and then in a little bit we'll come back around and we'll actually conduct the test to work out this example. Can virtual reality be used to enhance education? In a 2016 survey of teachers conducted by Samsung, 85% of them stated that using virtual reality in the classroom would have a positive effect on education. One educational specialist believes that the percentage has now increased to more than 90% since virtual reality equipment has become more available. She samples 500 teachers and finds that 471 of them believe that virtual reality would have a positive effect. Can she conclude that the proportion of teachers who believe that virtual reality would have a positive effect is greater than 90%? So here we have an example of a problem that calls for a hypothesis test about a population proportion. So this is review, right? This is the notation that we use for anything involving a proportion. We first introduced this when we looked at the sampling distribution for a proportion, and then we revisited it for the confidence interval for a proportion, right? P is the symbol, lowercase p is the symbol we use to represent the population proportion of individuals who are in a specified category. X is the number of individuals in the sample who are in the specified category. N is the sample size. P hat is the sample proportion of individuals who are in the specified category. And P hat is defined as X divided by N. Assumptions, these are really the same assumptions that we covered in the section regarding the confidence interval for the proportion. It requires that the sampling distribution be approximately normal. And so these assumptions will ensure this. The sample has to be a simple random sample. The population needs to be at least 20 times as large as the sample. The items in the population need to be able to be divided into two categories, and then the values n times p sub 0 and n times 1 minus p sub 0 are both at least 10, and p sub 0 is the value indicated by the null hypothesis. So here's the step-by-step procedure for conducting a test, and as you can see, the basic steps look pretty similar to what they were when we looked at the hypothesis test for the mean. Step 1, state the null and alternate hypotheses. Step 2, if making a decision, choose the significance level alpha. Step 3, compute the test statistic, and the test statistic in this case is the formula for the z-score, specifically from the central limit theorem for the proportion, right? Z equals p hat minus p0 divided by the square root of p0 times 1 minus p0 over n. So when we compute the test statistic, we are assuming that the null hypothesis is true. And so that p sub 0 there is the value indicated by the null hypothesis. And as long as your assumptions are satisfied, the z-score is a normally distributed variable. So there is no need to use the student's t-distribution for the proportion. Step 4, compute the p-value. And again, if it's a left-tail test, the p-value is the area to the left of z. If it's a right-tail test, the p-value is the area to the right of z. If it's a two-tail test, the p-value is the sum of the area to the left of negative z and to the right of positive z. Step 5, interpret the p-value. If making a decision, reject the null hypothesis if the p-value is less than or equal to the significance level alpha. If the p-value is greater than alpha, then we would choose not to reject the null hypothesis. And then finally state a specific conclusion in the context of the specific problem. So let's come back to our example. An educational specialist is studying attitudes of teachers about the use of virtual reality in the classroom. She samples 500 teachers and finds that 471 of them believe that virtual reality would have a positive effect. Can she conclude that the proportion of teachers who believe it will have a positive effect is greater than 90%? We use the 0.05 level of significance. First, we'll check our assumptions. If you go back to the original problem description a few slides ago, it mentioned that it was a simple random sample. So that assumption is satisfied. The sample size is 500, and the population of all teachers is certainly more than 20 times 500. So that assumption is satisfied. The null hypothesis, or the proportion specified by the null hypothesis, will be the 90% or 0.9. So to check our sample size requirement, we compute n times p sub 0, which will be 500 times 0.9, which equals 450. That is greater than 10. And then n times 1 minus p sub 0 is 500 times 1 minus 0.9, and that is equal to 50. And that is also greater than 10. So all of our assumptions are satisfied, and we can treat the sampling distribution as a normal distribution. So the next step will be to establish our hypotheses, right? Notice that the word greater is used, and that indicates that we'll be setting this up as a right-tailed test. So the null hypothesis is the assumption that the proportion is equal to 90% or equal to 0.9. The alternate hypothesis is the assumption that the proportion is greater than 0.9, right? Notice here that when we establish the hypotheses, we're using the symbol p instead of the symbol mu, right? And that's because we're doing a hypothesis test about a proportion, not a mean, right? The sample proportion is p hat, and we find that by taking 471 and dividing by 500, and we get 0.942. And then we compute the test statistic, which is a z-score. And for the population proportion, we use the value indicated by the null hypothesis, which is 0.9. Right? So 0.942 minus 0.9 divided by the square root of 0.9 times 1 minus 0.9 divided by 500. And that gives us a z-score of 3.13. So the p-value will be the area under the standard normal curve to the right of 3.13, which you can then find by either using the table or your calculator. If you use the table, you get an area of 0.0009. If you use the normal CDF command on your calculator, you would get about 8.74 e minus 4. So it's expressing the answer in scientific notation. The e minus 4 just means take the decimal place and move it 4 places to the left, right? So 0.000874. This just rounds it off to 0.0009. So whichever method you choose to find the p-value, you'll see that that p-value is very small. And if our value of alpha is 0.05, our p-value is significantly smaller than alpha. So we reject the null hypothesis at the 0.05 level and conclude that more than 90% of teachers believe that virtual reality will have a positive effect on education. And that's it. That's how we conduct a test utilizing a proportion. Let's now go over how to do the exact same type of test using your TI-84. So we'll revisit the exact same example, right? This is the virtual reality example, which calls for a hypothesis test about a population proportion. Notation is the same, right? No change here. Assumptions are the same. But when we get to actually conducting the test, we would access the Tests menu on your calculator. Again, press the Stat button and highlight Tests to get there. And the function you want is the one labeled 1-prop-z test, the fifth one down on the list. And it's pretty straightforward. You just enter in the information. There's a line for P0, that's the value for the null hypothesis, value for x, your x value, and then, your sample size. Then you choose a two-tailed, left-tailed, or right-tailed test, and then you just calculate. Okay. So here's our steps. Example, right? Assumptions are satisfied. So in our example, the null hypothesis is the statement that p equals 0.9. So in my calculator, I type in 0.9 right there. My x value is 471. My sample size is 500. I'm doing this as a right-tailed test. So I select the option for right-tailed, then calculate, and this is your readout. It gives you the test statistic, the p-value, sample proportion, sample size. Of course, the p-value right there is the most important number there because that's the number that you need to compare with alpha in order to conclude the test. We can clearly see that it is smaller than 0.05. So we would reject the null hypothesis at the 0.05 level and conclude that the alternate hypothesis is true. So that's a pretty straightforward way to do it using your TI-84. And again, I encourage you to practice doing these at home, and if you have any trouble, or feel free to reach out to me. For this section, that's it, right? We've looked at the notations used in performing a hypothesis test about a proportion. We've covered the assumptions necessary for performing a hypothesis test about a proportion. And then we've covered how to do the test using the p-value method, either using the chart or the calculator. So that wraps it up for this section. Thank you for watching.